Whole numbers, fractions, decimals, integers are all rational numbers because they can be written as a fraction with an integer over a non-zero integer. Irrational numbers are numbers such as the square root of 2, numbers who cannot be written as a fraction and whose exact value can only be estimated. All these numbers are part of real numbers, which are the only type of numbers students explore until high school, where they consider square roots, negatives, which are called imaginary numbers. Rational numbers comprise the set of all numbers that can be represented as fractions or a ratio of integers to an integer. Even with numbers are written as a whole number or as a terminating decimal, they can be written as a fraction, thus a rational number. In fact, in school mathematics, the term is rational number is often used to refer to fractions, decimals, terminating and repeating, and percents. Students encounter irrational numbers starting in 7th grade when they learn about the pi and continue exploring irrational numbers with more explicitity in other grades. Irrational numbers are not rational, meaning they cannot be written as a fraction, as we said before. Irrational numbers together with rational numbers make up the set of real numbers. The real numbers fill in the holes of the number line even when the holes are infinitely small. Activity 2215, repeater or terminator, on page 627 of your book would be a great activity to have students start figuring out if a number repeats or it terminates. In this figure, as you see, as students discover, the only fractions with terminating decimals have denominators, that factor with a combination of 2's and 5's. Why in this case? Middle school students must understand that any rational number, positive or negative, whole or not, can be written as a fraction and as a decimal. Every fraction can be divided to find its decimal. So a negative 8 can be written as a fraction of negative 8, fraction bar 1, or negative 16, fraction bar 2, because negative 16 divided by 2 is negative 8. Or as the decimal, negative 8 decimal 0, or just as number negative 8. In fact, there are an infinite ways to write equivalencies for negative 8. Fluency with equivalent representations is critical and requires much more than teaching an algorithm for moving from one representation to another. Activity 2216, edges of squares and cubes, would be a great exercise to help learn roots and cubes. This activity is on page 628 of your book. The square root of 6 is a number, not a computation. The cube root of 8 is the same as the 3 square root sine 8, which is equivalent to 2. Students encounter irrational numbers primarily when working with the Pythagorean theorem. A squared plus b squared will equal c squared, which is used to find the distance between 2 points. If a equals 3 and b is 4, then c is 5. All sides are rational numbers, but this case is an exception to the rule. Most often, sides will be something like 4 and 7, in which the c equals square root of 16 plus 49, which equals the square root of 65, which is an irrational number.